Welcome to Lesson 17, Greatest Common Factor. Lesson 17 of Numbers and Operations. Here's our objective, our vocabulary. I want to make a mention about equivalent fractions. Okay, equivalent fractions have the same value as a decimal, but they're just different numbers in the top and bottom, the numerator and the denominator. Okay, so let's look at our first example. Find the greatest common factor. So now, when we say prime factorization, that means breaking these numbers down to their prime numbers. And so we're going to use factor trees. Factor trees show you the factors of numbers, and we're going to go all the way down to the prime. So we're going to go far. So let's this example. 20 is 5 times 4, and 5 is a prime number, but 4 is not, so we have to keep going. So we go to 2 and 2. So all the factors, the prime factors of 20 are 2 times 2 times 5. And let's do 45. 45 is 5 times 9. But 5 is prime, but 9 is not. So now let's find the prime numbers that make up 9. So 3 and 3. Both 3 is a prime number, so we're done with 45. So the factors of 45 are 3 times 3 times 5. And so as we can see, if we compare the numbers, the only number that we have in common is 5. So the greatest common factor is 5. Okay, we'll do the same thing for 49 and 56, looking for the greatest common factor. Well, I know by looking at a multiplication chart that 49 is 7 times 7. And so the numbers, the prime numbers will multiply. And the numbers that make up 56 are 7 times 8. And 8 breaks down to 2 and 4. And finally 2 and 2. So the prime factors of 56 are 7, 2, 2, and 2. And all of these numbers multiply to each other. And as you can see, the prime numbers, the greatest common factor of these two things are 7. So the greatest common factor of these two numbers is 7. And that's it for our examples. Meet me at the end of this video to practice your problems coming up in the next couple of slides. But meet me at the end of the video for a wrap up. Okay, so 25. You're going to have to practice these things, but 25 are 5 and 5, and 85 breaks down into 5. And how many times does 5 go in that 85? And how do I know that 5 goes into 85? Because the number ends in 5. So 5 goes into 8 once. 1 times 5 is 5. 8 minus 5 is 3. Bring down a 5. And I get 17. So 5 and 17. Well, 17 is a prime number, so we're done. So as we can see from the factors, from the prime factors, 5 is the greatest common factor of 25 and 5. Okay, 84 and 108. Well, here's a little trick that you may remember from the notes when we did division. 84 ends in a 4 and 108 ends in an 8. If both of these numbers are divisible by 4, then we can divide by 4. So let's try dividing 84 by 4. And we can see when we divide 84 by 4, we get 4 and 21. And neither 4 nor 21 are prime, so that 4 goes down into 2, 2 times 2, and 21 goes into 7 times 3. So writing all these factors in numerical order, you get 2 times 7 times 3. Well, that's out of numerical order, but you'll forgive me. Okay, so 108 divided by 4. 4 times 2 is 8. 10 minus 8 is 2, 28. 4 goes into 27 times. And look at that, we get 4 and 27. Neither one of these numbers is prime. I'm going to change colors on you. I'll get 2 and 2. And then we'll get 3 and 9. 2, 2, and 3 are prime, but 9 is not. So now we got 3. And so we got 2 times 2 times, how many 3s do we have? 3. 3 times 3 times 3. Okay, here we go. Now, this is a little different. How many prime numbers do we have that are same? We got 1, 2 here and 1, 2 here. Okay. You got a 2 here and a 2 here. Okay. You got a 3 here and a 3 here. Oh, look at that. So all 3 of these numbers are common. And what does that mean? That we're going to multiply 2 times 2, which will give us 4, times 3, which will give us 12, and the greatest common factor is 12. And you can look on your multiplication charts and see 84 and 108 in the 12 column. Okay, problem 3. 49 breaks down into 7 times 7, 7 times 8, which gives us 4 and 2, which gives us 2 and 2. And we can see that the only numbers that they have in common is 7, so the greatest common factor is 7. And finally, the last problem. 3. 3 breaks down into 3 and 1, so 3 is already prime. 24 breaks down into 3 and 8. And 8 breaks down into 2 and 4, and 2 and 2. And the only numbers they have in common is 3. A number is a factor of itself because 3 times 1 equals 3. And that's one of our identity properties from a previous video. So thank you for watching this video. This is the second in a series of 6 videos before we get to adding and subtracting fractions. Hit the like, subscribe to the channel, and check out more videos.